Hi, welcome to Reno High. I'm actually Paul Goodfellow, and I teach here at Reno High School, and I teach multiple grade levels between 9th and 12th grade, but I teach mathematics. I actually have a history of teaching mathematics for the last 16 years, and I put together these lessons for you so that you can see some of the technology we use here at the Husky house. One of those, the class that you're going to actually see today happens to be an Algebra 2 class that is just being introduced to a new technology of the TI-84 calculators. These happen to be an actual, this is the actual calculator itself right here. This actually happens to be a recommended or a necessary item for students to use in our classrooms in Algebra 2 and beyond into college, because of its technical capabilities of using graphing of systems of equations. Now that's the first lesson that we're going to be talking about today, happens to be learning how to graph just simple systems of equations like lines into the graphing calculator and using it to help us find solutions between two lines that cross on the actual graph. Now, outlining some of the tech that's going to be used in this lesson, and has been planned ahead of time, was of course the TI calculators themselves, which students have been asked to get as a prerequisite to the class at the beginning. Also, I'll be using the Promethean board, the digital Promethean board at the front of the classroom for my presentation, and I'll be modeling on that actual Promethean board a digital TI-84 calculator to actually show step by step how you use the calculator that's sitting in front of you. As a response device to see how things are going during the actual lesson, connected to my Promethean board is also an actual active expression. What these are remote signaling devices that use infrared signals so that I can get instantaneous results of how students are working in the classroom and see whether or not there are difficulties or inconsistencies during the actual lesson, so I can find out that kind of data from these. They're just a signaling device to help students that don't like to raise their hand have to raise their hand. So I hope that you enjoy the video that follows here, and hope that you get some insight to the kinds of new technologies that are being used in the classroom. Thanks. Okay, so first we're going to use what's called a tabling method. Okay, now a table is just like you guys used to use in Algebra 1. You guys remember making actual XY tables where you would do an X and a Y table, and you would make a list of X values and then you plug them in and get Y values to come out? You guys remember doing that? The normal values were like -2, -1, 0, 1, and 2, and then you would pick them up and plug them in. You guys remember doing that kind of way? When you first started learning how to graph. Now your calculator does the same idea, because it's very, very good at actually plugging numbers in very fast and getting numbers out on the other end. Okay? Now what we're going to do is we're going to do a sample 2 equations. Right here, you see these 2 equations that are listed at the front of yours? Okay? I'm going to ask you that we're going to first put in those 2 equations into our calculator. Now I'm going to show you a structure of what you want to actually do. So those 2 equations are 2x plus 4 and -3x plus 44. So the first thing I want you to do, and I'm going to model this on my own calculator up here on the screen, is you've got your screen. First let's talk, so what we're going to do is we're going to actually input that very first line, just like it is in slope-intercept form, on line y1. So we're going to put 2. Now here's the next question. Where's the x key on this? Because we want to be able to put a variable in there for x, and just diagonal of the blue key, the second key, you'll see an x, t, theta, n key right here. This is your variable key. You just push it and it'll put an x in for you. There's no reason to alpha or anything. That's always the one that we'll use, is the x key. And then go plus 4. Plus 4. Now you've given that calculator a piece of information about what line you're actually talking about. Now the cool part is, this calculator will not only graph 1 at a time, it'll graph 2, 3, 4, all the way up to 10 lines at a time. If you wanted to find out where they all intersect, you could. So let's put the second one on the second line. This thought right here why would this be a question that I would choose to use my calculator on rather than use it on graph paper? Just look at those two equations and give me a reason why. Sage, what would you think? You got it. This y-intercept right here is 44. So it's like, in terms of where it is on the graph, it's like, woo, it's way.
That's utterly amazing.
That's absolutely right. So just go second and this graph key up here at the top, and it'll actually generate for you a table of values. Just like you used to do in Algebra 1. Now we used to make our table between -2 and 2, but this calculator allows you to actually make a table that goes anywhere you want. And you're allowed to go up or down that list as much as you possibly want, okay? Now what we're searching for here is a location where these two lines will cross each other. Where if I put a number in for x, what should happen in these two columns? Can you think about what should happen in each one of those columns? I put a number into each one of them. I want them to return the same number out. So what I want you to do is look through both this y1 and y2 list and scale up and down until you can actually find a location where they both turn out to be the same. Can you find it?
Holy cow!
You guys please put in number 1 into your calculator, so erase your y1 and your y2, and put in y equals 2x plus 5 on the top one, and y equals -x plus 2 on the second one, and use your table to see if you can come up with a solution for this. Okay? See if you can come up with an actual solution for that particular question. Now, when you get that actual answer, tell me, and then we will poll on it and see how you guys actually did. I'm going to open up a polling on number 1 and number 3. Now, when it asks you for this polling, I can't make you put it in as a coordinate, so look at your device for just a second. It's going to ask you, number 1, which value is it going to ask for first? It wants the x coordinate, so you put in the x part of the coordinate, and then it's going to ask you for the y part of the coordinate. Does everybody understand that in the polling? Okay? And then once you get that one pulled in, try number 3 and see if you can come up with a solution for that one.
I'm really going to milk that concept. Move.
All right, so let's wrap it all up. First off, how did that cow make it into my videos? Sometimes you just can't trust a kid to do your editing. Well, first thing I'd like to do is thank my editor, Mason Najama, who actually helped me put together the video stuff here and then decided to have a little extra fun with it too at the same time. Kids and technology, what should we do? Secondly, I'd like to thank Tech is Good for actually the opportunity for getting this chance to get some ideas out there onto the internet and for people to see what kind of great things we're doing inside the classroom. So thanks again, Tech is Good. Last but not least, if it turns out that something happens on the internet and I win this thing, they've asked me what I would do with the actual prize money in the end. And first and foremost, I think that tech is a wonderful tool in helping engage students, but it's also a wonderful tool in helping engage teachers. And here at Reno High, we're dealing with a very old facility, and we have some difficulties getting technology to certain teachers. So I would really like to take the prize money and help engage some of the other teachers in my department, in the math department, in getting some of the technology that we're using through about half of our department with Promethean boards and active expressions and some of the software ideas that work well in teaching this. Now, in doing so, by getting more teachers involved with more of the technology, it actually helps us engage more as teachers across curriculum and be able to share ideas. Because if one teacher doesn't have tech and the other one does, then there's usually this boundary that is listed between the two and doesn't allow those teachers to cooperate and actually work together on certain issues. So first off, I think working with this money in towards my department and helping other teachers get some technology is the way I'd use the prize money most of all. Secondly, there is a piece of software out there that I've been really looking at that uses Promethean technology as well. Most kids now have what are smartphones. You can see Mr. Goodfellow's still pretty low tech with his phone. Yeah, I got an actual keypad. That's a step up for me. But most kids are using smartphones at this point in time. Well, actual Active Inspire has decided to look for software issues that would help engage students that have those kinds of smart devices, and it's called Active Engage. If you get a chance to look on it, look on the Promethean Planet website for Active Engage. It works very similar to our Active Expressions, except that it turns all Android, all smartphone, and all iPad actual components into this particular device. So it becomes much more universal for students in the actual hardware that they use on a daily basis. And they'll be allowed to actually connect to a local network server, and then I can use those as response devices in the classroom. So it eliminates that piece of hardware, this piece of hardware, and incorporates only a software connection with current technology that students would have in their own possession. So I thought that would be a kind of a cool route to start to explore and see whether or not those smart technologies are something that would be useful in the classroom. So again, I wanted to thank you for watching, and I hope you enjoyed the lesson and seeing what kind of cool things we're doing here at Reno High. And again, thank you again to Tech is Good and Kelly for helping me with this nomination process. I hope you guys enjoyed. See ya!